Okay, so it turns out that synthetic division is really useful for a bunch of work that we can do in this chapter. And so one of the things we can use it is when we do what's called the remainder theorem. So remember the division algorithm? It says f of x, probably don't remember, it was a couple videos ago, but it says f of x is equal to the divisor times the quotient plus the remainder of x. Well, what if the divisor is x minus some number, x minus c? Okay, so then I would have x minus c times some quotient plus some remainder polynomial f of x. Okay, well, let's say you want to evaluate the function at c. Then you would have c for all those x's, right? Okay, so what happens is c minus, okay, so all I did was put in c for every x, right? Okay, this is 0. So that means this whole thing is 0. So f of c, the evaluation, is just equal to the remainder. Now, the remainder could be the polynomial, but it's most likely not going to be because you're always dividing by a linear factor. So it's just going to be a constant. This is going to be a constant. Okay, so now we can try it. Well, let me explain a little bit more what it means. It means if you want to evaluate a polynomial, it could be some huge polynomial. All you have to do is divide synthetically by whatever c is, whatever the remainder is, that's the evaluation. Okay, now I can give you an example here. So say you have this polynomial, and it says use the remainder theorem to find f of 2. That means 2 is the c. So we're going to go synthetically, put 2 in the box, pull off all the coefficients, there are no missing terms. Okay, now we're going to divide synthetically. Bring down the 1, 1 times 2, negative 2, negative 2 times 2 is negative 4, get 1, 1 times 2 is 2, multiplying, and then 3 plus 2 is 5. What that means then is f of 2 is equal to 5. Now you might be saying, well, that's like a little trick. How do I know that's really true? Okay, let's try it. How do you normally do an evaluation? You go f of 2 equals 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. See, now this looks like a lot of work, but that's okay. We'll just prove that it's true. 2 cubed is 8 minus 4 times 4 plus 10 plus 3. Okay, 8 minus 16 plus 10 plus 3. Let's see, what do we want to do? You could add up all the positive ones. We'll just go in order. Negative 8 plus 10 plus 3, or 2 plus 3, which is, in fact, 5. That's what we said it was, 5. Right? Okay, so this is more work, I think, though, than the synthetic division, right? Once you get the hang of the synthetic division, it goes pretty quick. So we can evaluate a polynomial just by using synthetic division, okay? All right, that's the remainder theorem.